Hi there. Behind me you can see a kind of a wave moving. This is called a noise wave. And if you've played around with p5.js examples, you've seen this before. Let's go to the example page. If you go to the p5.js example page and you scroll down and you get to, I think it's maybe math part. Yes, math part. Click on this noise wave here and take a look at it. You might have already done this. If you have, you're already way ahead. This is such a powerful tool, and this form artistically, this waveform here, is a really powerful tool. So I thought today in this video I would mess around with that and show you some really simple basic things that you can do that's going to create some amazing procedural art. So let's get started on that. So here's the program that we're going to do today, and it does more than just this. This is the basic element, and then we're going to manipulate this in some interesting ways to get some cool art to come out of that. So the very first thing I wanted to do was mess with this some so that I can show you what we can get it to do. So this is that same noise wave, and I've kind of colored the screen. I've set the graphics attributes so that it leaves this trail behind, and I've filled it in a certain way so that it erases some of that when it goes back and forth, and that just creates this interesting pattern. So what happens if we rotate this line around a center point, or around the center of the screen? So let's do that here. I think I have it right there. So now we're going to rotate this around and take a look at the pattern that it makes. So each time it steps, it's stepping through the noise, and then it leaves an artifact of that geometry before it's erased eventually. And collectively you can see it has this 2D wave noise pattern where it looks like land, or like a map or something. Maybe clouds. Clouds is one of the things that you can get to come out of the patterns of noise. So that's just one. What if we make more than one of these objects? What would that look like? So let's have several moving around the center. You can see what that does. So this is what we're going to do today. We're going to create a noise wave just like in the example, and we're going to move it around the center point, and we're going to make many of those do that and see what patterns we can get to come out of it. So okay, we've opened the p5.js editor, or however you do it. You might do it locally on your computer, you can do it in your browser, however you do it. We're going to go to the editor and start a new sketch. Let's instead of having the available window width and height, let's set this to some kind of uniform geometry. So I'm going to go by 800 and 600. So I'm going to fix the width and the height there. You might want to play around with this some, because the size of things are factored by either the height or the width. So if they're not in like equal ratio, like 1:1, then you might want to figure out which one's the longer one or which one's the shorter one, and use half of it to set stuff, and you'll see that later. So for now we're just going to use 800 and 600 for the canvas width and height. It also moves faster when it's kind of short screen like that. We need some global variables. We're creating an object, this wave that we're going to move around the center. We want to make many of those so we can move lots of them around the center at the same time. So we need a variable to hold that object, and we're going to put it into an array. So let's declare the array. I'm going to call it arm. You can call it whatever you want. So here's an empty array in p5.js set to the variable arm. The next thing we need is how many arms. Well, let's just start out with one and make sure that works, and then we can grow from there. So that's all of the global variables. Inside setup, we need to create a loop that's going to go through and instantiate all of the number of objects that we need in our array. We're only doing one for now, but when we go up in numbers and maybe want 12 arms or 8 arms or whatever it is, then we've got the loop that can do that. We're going to use a variable I in our loop for the index value. We're going to use that variable popu for population. That's going to be our limit on this loop, and we're just going to increment one integer at a time We're going to use our variable arm, which is that empty array, and we're going to push into the empty elements instances of this object we're calling WaveMaker, which is going to be a function we're going to create here in just a moment. That's all you need in setup. Now in draw, it's simple. We're just doing that same loop again. If you want to, you can go up here and copy this. See if I can figure out how to do that. There we go. Put that in there, and in the inside of that loop, now that we've created that object, we have to tell p5.js which element are we working with and what do we want to do with it. Well, we want to run a method inside the function that we're going to create, and we're going to call that method update, and we need to pass in some information into update. I don't know if I might be using it in this version, but it's one of those variables that you pass into it just so you can create some variety in a certain order. So I'm passing the index value into the method that we're calling for each one of the elements in the array. Once you have that done, we're ready to work on the function. That's pretty easy. The setup and the draw is so basic and easy for this. That means that if you want to incorporate this function into another program, it's going to be really easy to do. So let's create this function called WaveMaker. Do this with the standard. We're going to have some starting variables, but we know we're going to have a method or another function in this function. We've called that update. So let's create that now while we're thinking of it. And we're passing into it a variable, so we need something to accept that. And I'll just underscore I will represent that variable inside this function. So up here in the instantiation part, we need some variables to work with. We need a size of the wave increment. So in the example noise wave that they give, they use a loop and they assign x to that loop, and they're going from 0 to the width. That's their total distance that they're traveling through that loop, and they're incrementing by 10, I think, every cycle. So that increment of 10 is hard-coded in the noise wave example, but we're going to use a variable for that distance, that incremental distance. We're going to call that size. So instead of using 10 in the loop, the increment of the loop, we're going to use this variable instead. Then we need the y offset in the noise wave example from the p5.js example website. It has some global variables. We're going to put those global variables inside the instantiation part, and one of those is y offset or y off. So we just put this dot in front of it so that it's a part of this function, and we're going to assign that to 0 because I think that's what it does in the example part. I'm just going to look real quick for you guys. Okay. And then inside draw, that's where they do everything in the example. We're going to do everything inside our function, specifically update. So basically, if you're taking the example from the p5.js website and you're turning it into a function, this update method is going to be the draw part of the example. So we're going to put everything in draw pretty much in here. It gives you some idea of how we're changing it from this regular program with no function part into a program that has a function or a method to that. We need one more variable. When we rotate all of these objects, we need a variable to do that. So we're going to call that R off. We may want to use a sine wave, or we might want to use noise, or we just may want to increment it a set amount. However we want to rotate these objects around, we have a variable to use for that. So that's all of our instantiation variables for this function. Now inside update, we want some local variables. I think that's what it does in the example. It uses local variables in draw. We're just going to use a local variable in our function called xoff. And just to keep things cognitively consistent, I'm going to create a local variable called yoff, and we're going to assign our function variable yoff to it, and that just keeps it consistent. Now I can forget the this dot and it's still going to work. We want to isolate the shape that we're going to make, which is this waveform, inside push and pop, because we have to do some transformations. We might want to rotate, which we're going to do. And if we rotate, we want to rotate each object relative to the center. And to do that, we needed to isolate the translations because they're cumulative. I put too many syllables in there. Cumulative. They're cumulative, the translations are. So you isolate them and push and pop, and it keeps their translation from accumulating out of the position that you want it to be in. So I'm going to rotate, and I'm going to rotate by eye. This is where the index value comes in handy, because I can space out each instance in my array, each element in my array. So if I didn't do this, if I just rotated it by R off, they're going to be overlapped pretty much on top of one another. But I can separate them out using this value that I've passed into the function. We want to see the lines fairly good, but we don't want them to be overbearing. So a stroke weight of 2 is fine there. And for now, we're just going to use white for our stroke full alpha intensity, and let's fill it with black so that it will erase the line when it goes in certain directions. Now we need to do our loop for our wave. Everything's set up and ready to go. We need begin shape, that's part of the example, and end shape. Inside that, we need a loop that's going to represent X in this waveform. And we're going to move X across from 0, because we're translating to the middle of the screen is going to be translated to an origin value, 0, 0. So wherever our origin is, it's going to be 0. It doesn't matter if it's the left side or the right or up or down or backwards or forwards. So we're going to start with 0, and that's going to be where it needs to be. The length of that line is what we have to kind of calculate in a certain way. I'm using the height because that's the shortest of the dimensions of our screen, of the canvas that I'm using. And I'm going to use half of that because the wave that we're using is being rotated around the center of the screen, so it's a radius. So we're going to have the height of the screen, which would be the diameter of a circle. And that's what we get when it goes all the way around. It's doubling itself and it's creating the full height size. Does that make sense, or was that the worst way to explain it? Anyway, we're taking our height and dividing it by 2 so that when it goes all the way around the screen, it's going to create a full circle roughly the size of the screen or our canvas. We're going to create a local variable just like in the example that holds y. So now we have x in our loop, we have y in this local variable, and we have to find the relative value of this noise. We're going to use x off and y off in our noise, so it's two-dimensional Perlin noise values. It's going to return a 0 and a 1, a value between 0 and 1, and we're going to interpolate that to the size of our line times some number. I'm going to put 8 here and 8 here. So basically what this is saying is, as the wave is going up and down, this is how much it's going up and down by. It's going down by the increment size times 8, and it's going up by the increment size times 8. You can play around with that and get lots of different things to happen. So now we have our loop for x, we have our local variable for y. We're ready to create our vertex, which will hold the x and y value. Now something extra that I do here just to get some kind of cool pattern, like 8-bit pattern, I take x and I'm going to add the size of the increment, which is kind of arbitrary. I could put anything there, and just kind of move over. I'm going to move over. I'm going to stay at that y position, And then the next step through, it's going to move up, and it's going to create this kind of aliasing, this jig-jag pattern. After I've done all of that, I want to move my X offset so that I'll get a different range of Perlin noise returns. And that should be the end of that loop. And then just after the loop closes, I need to advance my Y offset so that I can get some new values there. So we're going to advance the Y offset by a certain amount. Now keep in mind, if you up this value, it's going to increase the time, it's going to speed things up. And if you lower the value, it's going to slow things down. You're still going to get the same height values of the wave. They're just going to move faster or slower through them. If you go up and down on this X value, that's where it's going to smooth the wave out or make it really mountainous. So that's adjusting those variables. That's what's going to happen, and you'll see those results immediately. So we've got our closing pop there, and I think that's all to this program. So let's run it and see what happens. Hopefully everything is working out okay. Let's change the background from 220. What are we going to do with this background? I don't want it to erase everything per cycle. I want it to erase a little bit per cycle, like so much alpha per cycle. And that's going to create this fading, this whispering kind of stuff here. So it's not rotating because I don't have this value in there. So I need to put that in there. We can just do that right off the bat here. This R off. Now if you increase this, it's going to spin faster. If you decrease it, it's going to spin slower. Now this has a lot of performance demands, and as you go up in the number of elements in the array, so let's make 12 of those and spin them around the center, it's going to slow down the rotation because it's taking longer to go through these loops. So if you're making a lot of these elements, you might have to go up in the rotational value to get it to look like it's spinning the right speed. But that will make it look almost stroboscopic, like jittery when it moves. If you're wanting to create some kind of video or something with this, what I would recommend is you just run it at its, just run it like it is, let it go its slow speed, and then put it into some software and speed that video up and record it that way. That's probably the best way to do it. When you start trying to speed things up, jumping these values, you're skipping through a whole range of adjustments that should be made. And instead of them being made, it's just flying to the next position, and it creates this jitteriness where it's not very fluid. So let's do some things with this. I've already shown you how you can make more elements there. What happens if we fill things and don't fill them? So we're going to close this shape. It's going to create a line. It's going to draw a line from the start of that wave to the end. And then wherever the peaks of the waves go, it's going to be filled with some color. We can fill it with whatever color we want. We can make a noise, some kind of noise wave, and map it to color values and plug that in there that way. So you can see how you can have a lot of fun with this, a lot of fun. One of the things that you can do is mess around with these values here. Maybe we can go by a diagonal here. Did I times that? I just want to add it. Just add vertices with, add vertexes with different variables or different arguments in here. I created something that looked like an aurora borealis. If I still have that, I accidentally erased a bunch of them just trying to clear out these video segments. So if I still have it, I'm going to put it here. All right, well, enjoy this program. Have fun with it. Add what you want. But I thought it was a cool idea to take that noise wave and spin it around the center. In fact, when I first saw that example, that was one of the things I wanted to do. I was like, oh, I want to spin lots of those around the center point, see what happens. I couldn't even make a function at that point. I was just learning code. I was just going through the examples for the first time and looking at all of them and being like, what can I do with these? And that's one of the things that I wanted to do. Well, I've eventually, after a year of coding, learned how to do functions and arrays, and I remembered that this was something that I wanted to do and sat down and was like, okay, let's try this. I think I can do this now. And it was pretty easy. I tried to make tornadoes using noise waves, and if you look at these objects, they kind of look like funnel clouds every once in a while. Here, let me make fewer so you can see. Okay, you can see they kind of look like tornadoes. You see that looks like a tornado, that looks like a tornado. I did an exercise where I was trying to create a funnel cloud using Perlin noise and making it wider at the top and narrower at the bottom. And I did it a completely different way, and it was quite deliberate. And it didn't look very cool. Here, I wasn't even trying to make this shape, and it just did it on its own. It made it on its own. So this is a way that I could have made a tornado, just instead of it spinning around the center here, just don't have it spin around the center, just have it straight up and down and move over the ground, and it would have been the exact same output, or fairly much the same output, but done in a completely different way. So I love that about coding, is that there's dozens and dozens of ways to do things. Now, there are optimal ways of doing things, and they're optimal for several reasons. One, they might save processing, or they may save time in writing the code, or it saves time in if you have to go back and change anything, and others know the standards you're following. Those are all optimizations. But unless you're working for Microsoft or somebody like that, if you're a hobby codist, you don't need to know optimization. Just do the code how you want to do it. If it's a sloppy mess, well, you're going to pay for that later when you try to go back and change it. So you're going to learn the processes, the optimizations that work best for you. So optimize things for yourself and help yourself along that way. But don't get all bent out of shape if you've done something one way and somebody else has done it a different way, and you feel like the way that you did it was wrong. Did it accomplish what you wanted to accomplish? Well, then you did it right. So don't sweat it at all. Maybe I'm telling myself that. I don't know. Maybe it's a little something personal. But if you're feeling that way, every once in a while I feel that way. It's like, why did I do it that way? Seems like it's a better way to do it. Well, it might be better. Maybe it is, maybe it isn't. But understand there are lots of different ways to do things. And depending on what the overall needs are, that will dictate whether or not it has to be optimized or should be done this way versus that way. What are you doing with this later on? Did you think ahead when you made this so that later on if you wanted to do that, then you can do it? You don't have to completely back up and redo your work over again. So optimizations can involve thinking ahead and making your code so that it's easy to plug into other stuff. I would recommend that as a hobby codist. Otherwise, don't sweat it. Really don't sweat it. But have fun with this code. Enjoy it. Make all kinds of art and stuff. And I want to warn you though, when I was working on this, I kind of made myself sick because the spitting pattern had trained my eyes subconsciously, just kind of like tracking things and refining the artwork. I'm staring at it for minutes at a time. And then when I look away, I wonder why I have vertigo. Why is the room moving? Why do I feel like I'm drunk? Well, it's because my eyes did this optical effect staring at the spinning. So just be aware of that if you're working on this and you suddenly feel like you're drunk or you're on some kind of pills or something. It's the spinning effect getting to you. So take a break, a few minutes away, and you'll be just fine. I guess that's it for this video. I hope you've enjoyed it. If you have, give me a like. If you want to see more, hit subscribe, hit the bell to be notified, and please leave a comment. Let me know what you think. I would love to hear from you guys. I don't hear too much, but when I do, it's usually okay, so I enjoy that for now. So please leave a comment. Let me know what you think. And I guess that's it. Thanks for watching, and until next time, take care.